All right, so here we are on page 3 of the notes for section 10.3, and we're going to look at some of the application exercises, some of the real life type or story problems that you're going to see that involve quadratic equations, trying to solve them, and we have the opportunity to use quadratic formula now to do that. So as we've always done, we're going to read it, take a deep cleansing breath, read it again, see what they give us, see what it is, what our goal is, and realizing that we are in the section on quadratic formula, so we can expect to see a quadratic, and either it will already be set to 0 or we will have to set it equal to 0, okay, and then use A, B, and C in the quadratic formula to solve for x. It's always good to kind of remind yourself now, what are we doing, so that you don't get too intense about these problems. Just remember the big picture. You can expect that this is what's going to happen, so you kind of know going into it what it's going to feel like and look like. It's basically the problems we've been doing, just with a story behind it. Standing on a platform 50 feet high, a person accidentally fires a gun straight into the air. I'm glad it was straight up into the air and not at anybody. The formula h equals negative 16t squared plus 100t plus 50 describes the bullet's height above the ground, h in feet, t seconds after the gun is fired. How long will it take for the bullet to hit the ground? Use a calculator and round to the nearest tenth of a second. So, deep breath. I'm kind of picturing what's going on in my head here. Let's read it again, and again we're looking for what are they giving us, and specifically what is the goal, what are they asking us to find. Standing on a platform 50 feet high, a person accidentally fires a gun straight into the air, so that's the background, the story. The formula, h equals negative 16t squared plus 100t plus 50, we don't even have to set it up, they give us the formula. Describes the bullet's height above the ground, h in feet. So the height above the ground is h, and it's in feet. T seconds after the gun is fired. So now we know what t is, so it's how many seconds after the gun is fired. And there's our t in two different spots. Here's our h, the height above the ground. And here comes the question, how long will it take? Sorry, got a little distracted there. How long will it take for the bullet to hit the ground? Use a calculator, round to the nearest tenth of a second. So I'm just going to note that they want us to round to the tenth here. How long will it take for the bullet to hit the ground? Here's where you have a little instance of bring your own formula, bring some information to the situation. When the bullet hits the ground, its height will be 0. So it's sort of a BYOF here. At the ground, also if I can spell ground right. Oh, let's just try again. Ground, the h, height, will be equal to 0 feet. Okay, so that means we're going to replace that with 0. And there's our formula. And then they ask us how long, so our goal here is t equals what? We're going to be solving for t when our height h is equal to 0. So what we're going to be doing is solve for t, which makes sense. We just talked about that. That's what we would be doing in this situation. We would be solving for t and using the quadratic formula because we're in a quadratic situation. And now we've got it set equal to 0. It's already in standard form for us. So let's recap that. We started with h is equal to negative 16t squared plus 100t plus 50. We're going to replace that h with 0 because they tell us that we're trying to find out how long time is t before it hits the ground, and the ground height would be 0. And it's already set equal to 0, so I can go ahead and identify my a, b, and c value. Don't identify them until you've got the whole thing equal to 0. Otherwise, signs are going to change on you. So everything's on one side. Doesn't matter that it's on the right or the left. They're just all together on one side. A is negative 16, b is positive 100, c is 50. We keep the signs with us. And we're going to just remind ourselves that when we're solving for t, we're going to use the quadratic formula negative b plus or minus big old square root b squared minus 4ac, the whole thing over 2a. I started to put in my little filler pieces here. So now we'll do that. Negative b plus or minus big old square root b squared minus 4 times a times c, the whole thing over 2a. Let's plug in those pieces. Negative b, 100, b squared, there's another 100, a and c, negative 16 and 50, and then a again on the bottom, negative 16. Take those signs with, very important. And let's start simplifying. That gives you a negative 100 plus or minus 100 squared is going to be 10,000. Negative 4 times negative 16 times 50. Punch that through on your calculator. You should get 3,200, positive 3,200. Whole thing over 2 times negative 16, that's negative 32. Let's continue to simplify here. I get negative 100 plus or minus the square root of 13,200. The whole thing over negative 32. Now grab your calculator, see if that's a perfect square. Kind of have the tip off that it's not going to be. You can't imagine that in real life things are always going to land on nice round even numbers, and it does tell you we're going to round to the nearest tenth of a second, so no sense trying to make this any simpler. We're going to go ahead and just put it in our calculator, and when you do, realize that you've got two different answers that you're going to calculate. You're going to take negative 100 plus radical 13,200, or the square root of that, over negative 32, and you're going to look at negative 100 minus radical 13,200 over negative 32, and don't assume you know which one might be the right answer, okay? Obviously there's just one point at which it falls. What you get here when you take the negative 100 plus 13,200, you get like radical 13,200 is about 114.891. I take it out further. I don't round till the very end. So this is 114.891. So take negative 100, add 114.891, you get about 14.891. Divide by negative 32, you get a negative 0.46. Round that up to negative 0.5. Now that's great for an answer, but it doesn't make sense in the situation because we can't have negative time as our answer. So this one is a extraneous solution. It works algebraically, it doesn't work in the situation. So down below, negative 100 minus the 114.891, then you divide by the negative 32, you end up with a positive 6.715, or that rounds to 6.7 seconds. That's a pretty long time before that thing reaches the ground. It must have gone really high. And that's a problem for another time. We can talk about that when we get to the next section, 10.5.